What's up, guys? So in this video we're going to talk about how the domain and range of a function relates to the domain and range of its inverse. And to begin with, I put up this simple function y is equal to x squared plus 1. So I made a table of values. Let's fill in the y portion. So negative 2 squared plus 1 is 5, negative 1 squared plus 1 is 2, 1, 2, and 5. So taking these points and then plotting them, we end up with this parabola right here. So let's figure out what the domain and range is. Well, the domain of a parabola is always x is an element of real numbers. X can be any value. So this is xer. What about the range? Well, the y can be anything as long as y is greater than or equal to that minimum value of 1. This is a y value of 1 here at the minimum. So y has to be greater than or equal to 1. So now let's figure out what the inverse of this original function would be. So for the inverse, what we do is we interchange the x and y values. Another thing we could do is we could take the table of values and then interchange the x and y values. So this negative 2 and 5 becomes 5 and negative 2. This negative 1 and 2 becomes 2 and negative 1, etc., etc. And now let's plot these points right here. So let's start off with the vertex. So 1 and 0 is here. 2 and negative 1, 2 and 1. So 2 and 1 would be here. 2 and negative 1 would be here. And then 5 and 2 and 5 and negative 2. So 1, 2, 3, 4, 5. And then 2. So that's here and here. And then notice how this ends up being, the inverse ends up being a sideways parabola. Right, so this red sideways parabola is the inverse of this original parabola right there. And now let's figure out what the domain and range is of the inverse. So let's start off with the domain. What values can x take? Well, notice how x has to be greater than or equal to 1. It could take any value as long as it's greater than or equal to 1. So xer, but x has to be greater than or equal to 1. And then what about the range? Well, the y value for the inverse can be anything because this parabola keeps extending on forever. So the range is yer. So that's the domain and range of the inverse, and notice how it relates to the domain and range of the original function. So the domain of the original function was xer, and notice how the range of the inverse is yer. And then the range of the original function was yer as long as y is greater than or equal to 1, while the domain of the inverse was xer as long as x is greater than or equal to 1. So it's almost like the domain and the range got interchanged, which is a common theme with functions and inverses, right? We interchange the x and y values in the equation, in the table. Also, the domain and range interchanges. So to make a concluding statement about the observation we just made, so the domain of a function is the range of its inverse, right? So the domain of a function is the same as the range of its inverse, and the range of a function is the domain of its inverse. So the range of a function corresponds to the domain of the inverse. Another question that comes up pretty often with these types of questions is how can we restrict the domain and range of the function for the inverse to be a function? And notice how the inverse, this red sideways parabola, is not a function because it fails the vertical line test. So how can we restrict the domain or range of the original function in order for the inverse to be a function for it to pass the vertical line test? Well, if you remember, graphically, to get from the function to the inverse is just reflected on the y is equal to x line. So it's like this vertex of the original function corresponds to the vertex of this sideways parabola here. They're reflections of each other. This whole right leg of the parabola of the original function corresponds to this upper leg of the sideways parabola, right? They're reflections of each other. And then this left leg, this portion right here of the original function, corresponds to this bottom leg of the sideways parabola. This leg is a reflection of this leg over the line y is equal to x. So in order to make this sideways parabola function, if we get rid of this bottom leg here, notice how it turns into something similar to the square root function. And then it would pass the vertical line test. There would be no y values that touch the vertical line twice. So if we get rid of this bottom leg here, then that means that we have to get rid of this left leg on the original function because that leg was corresponding to that bottom leg. And then we can also show this in the domain and range. So here we're restricting the range of the inverse to be y is greater than or equal to 0. Right? So y is greater than or equal to 0. We can't have any negative values, and now notice how the inverse is a function. It passes the vertical line test. Well, since we restricted the range of the inverse, remember the range of the inverse relates to the domain of the original function. That means that we have to restrict the original function as well. So since we restricted the range of the inverse to be y is greater than or equal to 0, we have to restrict the domain of the original function for x to be greater than or equal to 0 as well. So that's the restriction on the original function in order for the inverse to be a relation. So the domain has to be restricted on the original function as xer, but x has to be greater than or equal to 0. So one more time, if we restrict, so let's redraw the original parabola. If we restrict the domain of the original parabola to be x is greater than or equal to 0, we get rid of this left leg, and then as a result we get rid of this bottom leg that left leg reflected. And then if we get rid of the bottom leg in the inverse, that means the inverse now would be a function because it passes the vertical line test. A little bit confusing. You may have to rewatch that explanation a couple of times, but whenever you run into questions like this, the best thing to do is to graph them and then see what you can erase from the inverse in order for the inverse to pass the vertical line test. And then whatever you erase in the inverse, you have to know what you have to erase correspondingly in the original function.